Fourier cosine transform. Definition: the infinite Fourier cosine transform of f of x, where x lies between 0 to infinite, is defined by f(c) of f of x, which is equal to f(c) bar of p, which is equal to root of 2 by pi integral 0 to infinite f of x cos px dx. The function f of x is called the inverse Fourier cosine transform of f c bar of p. This is same like Fourier sine transform. So instead of sine px, we are having cos px, right, in the integral. So f of x, which is equal to fc inverse of fc bar of p. So we'll see the inversion formula, right? So fc bar of p is the Fourier cosine transform of f of x, and f of x satisfies Dirichlet's condition in every finite interval 0, L. And further, if integral 0 to infinite f of x modulus f of x dx is convergent, that is f of x is differentiable, absolutely differentiable, then at every point of continuity of f of x, which is equal to root of 2 pi integral 0 to infinite f c bar of p cos px dp. So we know Fourier integral formula f of x, which is equal to 1 by 2 pi integral minus infinite to plus infinite d omega integral minus infinite to plus infinite f of v cos omega x minus v dv. So that is equal to 1 by 2 pi 2 into integral 0 to infinite dw, because minus infinite to integral minus infinite to plus infinite d omega can be written as 2 times integral 0 to infinite d omega, right? When you are replacing omega by minus omega, there will be no change. That is why that is like a even function. So into integral 0 to infinite f of v cos omega x minus v dv. Therefore f of x, which is equal to 2 and 2 can cancel, 1 by pi integral 0 to infinite d omega integral minus infinite to plus infinite f of v cos omega x minus omega v dv. Put omega equal to p, d omega which is equal to dp. There will be no change in the limit. So f of x, which is equal to 1 by pi integral 0 to infinite dp integral minus infinite to plus infinite f of v cos px minus pv dv, which is equal to 1 by pi integral 0 to infinite dp integral minus infinite to plus infinite f of v. We are using cos a minus b formula, cos a cos b plus sin a sin b, cos px cos pv plus sin px sin pv, right, into dv. That is equal to 1 by pi integral 0 to infinite dp integral minus infinite to plus infinite f of v cos px cos pv plus f of v sin px sin pv dv. Splitting the integration, 1 by pi integral 0 to infinite dp integral minus infinite to plus infinite f of v cos px cos pv dv plus 1 by pi integral 0 to infinite dp integral minus infinite to plus infinite f of v sin px sin pv dv, which is equal to 1 by pi integral 0 to infinite cos px dp integral minus infinite to plus infinite f of v cos px dv plus 1 by pi integral 0 to infinite sin px dp integral minus infinite to plus infinite f of v sin pv dv. So we are grouping cos px with the dp and cos pv with the f of v dv, right, on the both the integral, which is equal to 1 by pi integral 0 to infinite cos px dp integral minus infinite to plus infinite f of x cos px dx plus 1 by pi integral 0 to infinite sin px dp integral minus infinite to plus infinite f of x sin px dx. Just we are changing the variable. Instead of v, we are putting x in the second integrand of the both the integrations. It is equation number 1. So let us take f of x is an even function in minus infinite to 0, and cos px is an even function. F of x is an even function, product of even function is an even function. So f of x cos px is an even function by the Properties of definite integral minus infinite to plus infinite f of x cos px dx, which is equal to 2 times integral 0 to infinite f of x px dx. Since sin px is an odd function, f of x is an even function. Odd function into even function, you will get an odd function. So f of x sin px is an odd function. So from the definition properties of definite integral, in minus infinite to plus infinite, integral minus infinite to plus infinite, f of x sin px dx, which is equal to 0. Using these ideas in 1, f of x which is equal to 1 by pi integral 0 to infinite cos px dp into 2 times integral 0 to infinite f of x cos px dx plus 1 by pi integral 0 to infinite sin px dp into 0, which is equal to 2 by pi integral 0 to infinite cos px dp integral 0 to infinite f of x cos px dx. So splitting 2 by pi into root 2 by pi into root 2 by pi, right? Integral 0 to infinite cos px dp integral 0 to infinite f of x cos px dx, that is equal to root of 2 pi pi integral 0 to infinite cos px dp root of 2 pi pi integral 0 to infinite f of x cos px dx. That is equation number 2. We know from the definition of Fourier cosine transform, fc bar of p which is equal to root of 2 pi pi integral 0 to infinite f of x cos px dx. So 2 implies f of x which is equal to root of 2 pi pi integral 0 to infinite cos px dp fc bar of p, right, which is to be proved. Now Fourier cosine transform and its inverse can also be defined in the following form. In some other they will use this notation, right, f bar of cp which is equal to integral 0 to infinite f of x cos px dx and f of x which is equal to 2 pi pi integral 0 to infinite fc bar of p cos px dp. Thanks.